use differentiation to work out a tangent and a normal. Now, first of all, let's explain what I mean by tangents and normals. So if we have a curve of some description, let's not make it go through the origin, let's do a curve, something like that. And what we're interested in is knowing what's happening at this point. So let's imagine that this is a road, and there's a car going along the road, and it suddenly hits a piece of ice at that point. So the car's coming along here, hits some ice, so it doesn't go around that corner. What it does is it goes off in that direction. It goes off in exactly the direction it was traveling when it hits the ice. If we make that a line, then that line is what we call a tangent. Okay, so a tangent is a line that touches the curve just at that one point that we're interested in. That's what we mean by a tangent. And the normal is also a line, but it's the line that's at right angles to that one. Okay, so that's what we call a normal. And in our car example, that's effectively where the force has to act to keep it on the road. So when the force isn't there, it goes off on the tangent. Okay, so this is what we mean by tangent and normal. So they're both lines that touch the graph in a particular way. And hopefully you can remember that the equation of a line from general stuff, so the equation of a line from the algebra is y equals mx plus c as the equation of a line. And you may even have got really clever from when you did algebra and be able to remember back that far that m was the slope and c is the y-intercept. Okay, so to work out the tangent, we need the equation of a line. So we're going to have to work out the slope and the y-intercept for the tangent. Okay, the slope is what we've been doing with differentiation. So that's why this comes as a differentiation topic, because to work out the slope of the blue line, we need to work out the slope of the black curve. And once we've got the slope, that straight away gives us the value for m. And if we've got the slope and a point, we should be able to work out what's going on with c. Okay, so let's try something. Let's call this curve y equals x cubed plus 2x squared plus 3x minus 4. I have no idea whether that's what that curve would look like or not. Just made up a series. And we're going to find the tangent at x equals 2. Okay, so this is the point x equals 2, and we want to find out what the tangent is at that point. Okay, so the first thing we need to do is we need to work out what the slope is. And the slope is equal to the derivative. So it's equal to dy by dx at x equals 2. Okay, so we're going to work out what the derivative is. We're going to pop the value 2 into it, and that'll tell us what the slope is. So dy by dx, if we differentiate this thing, we get 3x squared plus 4x plus 3. Evaluate it at x equals 2. So when x equals 2, dy by dx equals, plugging 2 into here, what do we get? 3 lots of 2 squared plus 4 lots of 2 plus 3 equals some ridiculously big number for a slope. 4, 12, and 8 is 20, is 23, which is very, very steep. So it means for every one you go along, you go up 23. So my picture here is not very accurate. So it's a very, very big slope. But that's the value of the slope, is 23. And then we need to figure out the value for the y-intercept. And to do that, we need one point. So we need to find out also, at the point when x equals 2, we need to find out what the y value is. So we need to know what's going on along here. And this is going to be an even stupider big number on the one I've drawn, but when x equals 2, in this case y equals 2 cubed plus 2 lots of 2 squared plus 3 lots of 2 minus 4. So it's that 8 and 8 is 16, and 6 is 20. No, I lost the plot there. I said something stupid. 8 and 8 is 16, and 6 is 22, minus 4 is 18. Okay. So the point on the curve is x equals 2, y equals 18. So we now have a particular value for y, 18, a particular value for x, 2, and the slope, 23. So we should be able to figure out what c is. So now c equals y minus mx, rearranging. I'm going to tell you in a second, that was actually y. I said m, but I meant y. So y is 18, m is 23 from the derivative. X is 2, 18 minus 46 is 28 maybe. Not negative, it's going to be negative for a start, and that can't be right. 18 minus from negative 5, negative 28. Okay, this is the problem, is making numbers up as you go along. You haven't got anything written in front of you, and anything could happen. So we know that the y-intercept is negative 28. So the equation of the tangent is y equals mx plus c. Okay? That's the equation of the tangent for this particular curve, which, as you can see, looks nothing like this one. It's got a slope way to, maybe there's more like a point about here somewhere. Shoo, just doing something like that would be slightly more realistic. We also need to find the slope of the normal. The question is, how do we find the slope of the normal? And the thing is, if you think about it for a second, if the tangent's going uphill, the normal must be going downhill. The normal is going to have the opposite sign to the tangent. And if you think about, if the tangent's flat, the normal is very steep. If the tangent gets steeper, the normal gets flatter and flatter. Okay, so they've got an inverse relationship. And the way it works out is that the slope of the normal is negative 1 over the slope of the tangent. Okay? So once you've got the slope of the tangent, then to find the slope of the normal, you just do negative 1 over that. Okay, so in this case, the slope of the normal, negative 1 over the slope of the tangent, is negative 1/23. And that will give us the slope of the normal. And once we've got the slope of the normal, we've got a point, we've got a slope. We can just go through this process again to work out c for the normal. So for the normal, c equals y minus mx. Y is still 18, minus m is still 23. No, it's not. That's a big lie, isn't it? M is now the m for the normal. Thank you. Okay, so m for the normal is negative 1/23, and x is 2. So what do we have here? We have 18 plus 2/23. So I'll be a bit naughty and write that as 18 and 2/23. So the equation of the normal is y equals m x plus c. Okay, and the key thing for both of these is you end up with an equation. So the equation of the tangent, y equals mx plus c. Equation of the normal, y equals mx plus c. So for both of them, it's an equation that you're looking for, because the normal and the tangent are both lines. Okay? And you find the slopes of the tangent directly from differentiation, and of the normal by using this relationship between the tangent and the normal. Okay? So that gives you a way of working through to get the equation of a tangent and the equation of a normal.